which is proportional, integral and derivative control compensators. Okay, earlier we have seen phase lead, phase lag and combination of phase lead and phase lag. Now we will see the proportional, integral and derivative control. We will see what each type of compensators is. Then we will see the effect of each. Okay, the first one, proportional plus derivative controller. See, I'll just draw the middle part. Now this block will be act like a, will be go in a system either in forward path or in the feedback loop. A proportional constant. KA. Okay, so this is the proportional plus derivative control. Now if I write the overall equation of this, and transfer function of this will be Kp multiplied by Ka plus Kds is equal to Kp Ka 1 plus Kd by Ka into S. Okay. Now this is addition. Putting at this type of controller in a system is means that we are adding a zero. Equivalent to addition of 0. So what are the effects which are caused due to addition of 0 will be due to this type of controller also. Okay. Effects. The first one is damping factor increases. Natural frequency, no change. Settling time reduces. Okay. So these are the effects which are due to proportional plus derivative controller. Next is proportional plus integral controller. Okay. Instead of derivative factor KdS, I will use the integrative factor Ki by S. Okay, the transfer function of this is equal to Kp times Ka plus Ki by S is equal to Kp Ka 1 plus Ki by Kas. Okay, so addition of this controller in the system is equivalent to addition of poles at origin and 0 at some location. Okay, that means if a pole is added at origin, that means the type of a system is increased. Effect. First one, the type of the system increases. Okay, it improves steady state performance. Second affected, okay, error due to ramp input decreases. So these are the effects with the proportional plus integral controller. Now the main thing is why we are calling it as a derivative controller and why we are calling this as a integral controller. Okay, so the reason behind this comes from the Laplace transform and the properties of the Laplace transform. Okay, we will see that. From the Laplace transform, if we take the first one, the derivative controller, I will use the derivative property. Suppose if xt is having a Laplace transform xs, then derivative of xt will have a Laplace transform xs by s into xs. Okay, this is the derivative property of the Laplace transform, and due to this the multiplication factor of s will come. That's why we have used in the proportional derivative controller kds. Okay, so s is in the numerator there. Second, if we look at the integral property, which says that if xt is having Laplace transform xs, then integral 0 to t, minus infinity to t, x tau d tau will have Laplace transform xs by s. Okay, so from here the s is coming in the denominator, and that's why in integral controller the s is in the denominator, and this add s in the denominator adds a pole at origin. Okay, so from these things the derivative and the integral controllers are derived. Okay, now within this there is a one more third type of controller, like in phase lead and phase lag we have seen one third type of controller which is combination of phase lead and phase lag. Similarly in this also there is one more type of controller which is addition of phase integral plus derivative. Proportional plus integral plus derivative control. So when I have something like this, for that I can write my equation as Kp plus Kds for derivative part plus Ki by s for the integral part. Okay, so this is my integral plus derivative controller. Now the effects of this. since the order of a system is increased, it becomes more unstable. It becomes, the instability comes more into the system. Okay. It increases system order as well as type, thus making it more susceptible to instability. Okay. Damping factor increases. So some effects of the integral controller and some effect of the derivative controller, both will come into this. Okay. Peak overshoot increases. Which is due to addition of 0. Okay, so these are the effects for the integral plus derivative controller. Okay, this is about the controllers due to derivative and integration. Okay.